There's something special called the fundamental frequency, and this is going to correspond to the longest wavelength, which is when you have m equals 1. That corresponds to the lowest frequency allowed. So this is when you have just one antinode. Remember that these are your antinodes. That's where you have your maximum amplitude, and your nodes here are at the end. So m equals 1 corresponds to one antinode, and if you think about the wavelength though, what we see here is only half the wavelength. To fully have a wavelength, you have to go up and then also come down, and it actually goes off the page. So that's why we say that the wavelength of this is actually 2L. What we see here is only half of the wavelength. So our wavelength is simply equal to 2L for our fundamental. We plug that in for the frequency and we get our wave speed divided by 2L. And this is going to be the lowest frequency allowed. That every other wavelength is going to be longer. Every other wavelength is going to be shorter, which means every other frequency is going to be higher. So if you're asked about what the fundamental frequency is, or you're told what the fundamental frequency is, just remember that the defining feature is that fundamental frequency corresponds to m equals 1. Then we have what are called harmonics, and harmonics are higher values of m. And when we talk about m or n, depending on what book you might be looking at, this is simply called the mode. So you can have m equals 1, m equals 2, which is not shown, 3, 4, and it can keep going. And in each case, you see that the mode number counts how many antinodes you have, right? So remember that your mode number does not count nodes. So m equals 3 has 3 antinodes, but 2 nodes. So the terminology here can be confusing. We have mode, we have node, and we have antinode. So do your best to try to understand what each of these mean, and be ready to be asked a question like, if you see this sort of wave, what is m? And in this case, recognize that even if you don't remember what the word is, count 1, 2, 3, 4 bumps, and that corresponds to your m equals 4. Now the reason that that's valuable is once you know that m equals 4, you can actually relate the wavelength of that mode to your fundamental wavelength. You can relate the frequency of that mode to the fundamental frequency. So all of these equations can always use for wavelength 2L over m and for frequency m times your wave speed over 2L, but these can also relate back to your fundamental. So sometimes we just jump between fundamental and a certain harmonic. Other times we talk about the geometry and calculate something from these other parameters. So again, if you're told what the fundamental is and you're told what mode it is, you can find everything else. You might be asked to find this the spacing of the nodes using this. You might be asked to find the wave speed. There's just always a lot of information here that you can use to calculate other pieces of information.